Okay, the first kind of interference that we're going to talk about is going to be double slit interference. So in order to illustrate this, let's go to FET, wave interference. So go to the internet and find that, and you'll come to this, wave interference for FET, and then click on it. Okay, and now we've got different kinds of simulations that we can look at. So in this segment, we're going to look at this very first segment here. So we're going to click on waves. And you'll notice that you have a faucet. So if you turn on the faucet, you see that it's dripping. And it's going to be dripping into a pan of water. So you can see that it's making ripples. All right, there's a couple of things that I want you to notice about this. So the first thing is that it's making these ripples, areas where it's bright and then areas where it's dark. The lines are going to represent where the wave is at its cresting. And then you have another crest over here. So what do you think is happening in the dark areas? So the dark areas are going to be representing troughs. And if you want to see that, you can, let me go ahead and pause it, and then go over here and click on graph. Okay, and now look at this line right here. It's bright, and that corresponds to a crest. This one is dark, and if you go down, that corresponds to a trough. So the black areas are troughs, and the blue areas are where it's cresting at. All right, so let's get rid of this. Okay, the next experiment I want you to do is I want you to manipulate the amplitude and see what it does. So this one, if I move it all the way over to the side, notice it gets really dark. Okay, that's because the amplitude is very small. So I would keep the amplitude over here on the other side where it's very, very bright. And then you can see the rings very easily. The other thing I want you to do is manipulate the frequency. Okay, so if I put the frequency and I make my frequency small, what happens to the wavelength? What was the wavelength? The wavelength is the distance from here to here. So it's going to be from one line to the next line. So notice if the frequency is small, the wavelength gets large. Let's try, what do you think is going to happen if I make the frequency large? See, it's dripping faster. And you notice that if the frequency is large, then the wavelength got small. Why is this true? Because the speed of any wave is equal to its wavelength times its frequency. So if one gets small, the other one has to get big in order to compensate. We could also change this from a dripping faucet to a sound wave, and you get a very similar looking situation. Notice that the further away you get, the weaker it gets. That's that 1 over r squared thing. And then we could also change it to light. So that's a particular color of light. And we could change the frequency. So by moving this back and forth, we could have red light or we could have blue light. Again, look at what's happening to the wavelength as you move the slider. Red light is going to have a larger wavelength than what blue light is going to have. And so just verify that. Okay, let's take a break. And when we come back, we are going to go to 2 faucets.